So before we come to some of the recent changes in Active Directory, I'd like to make a short review of the existing Active Directory replication procedure. And there were two design decisions that largely established how Active Directory was built. And the first design decision was to go with a multi-master approach. Why? Because there were high availability issues with the old concept with primary domain controller and backup domain controller, so they wanted to go multi-master. Did they succeed with that goal? Well, yes, almost, right? We know that there are 5 roles in Active Directory that are still single master, 2 for the forest, the schema and the domain naming master, and 3 for the domain, the RID master, the infrastructure master, and the PDC emulator. And as you know, the PDC emulator, it's not just something for reverse compatibility, but if you started cloning domain controllers on virtual machines, you know you want the PDC emulator working. We'll cover that in part 3. And the second design decision, that's an interesting one. They wanted to make sure that they were not dependent on time being perfectly synchronized between the domain controllers. Let's be clear, they do have a timestamp. It is recorded, and it is used for resolving conflicts. But they didn't want a time skew to lead to missed updates. How could this happen? Well, let's take an example. Let's assume that we have a change on DC1, and then we have a change on DC2, and then we have a third change to that same property on DC1. Let's see how that would work if the time was perfectly synchronized. Here comes the change to DC1. He sends it across to DC2 with the timestamp of 1 second past midnight. DC2 gets a change, an update to the same property. He makes a stamp of 1.5 seconds past midnight, writes it in his database. DC3 makes a third change to the same property, sends it across to DC2 with the timestamp of 2 seconds past midnight. And if the time was synchronized perfectly, everything would work fine. But let's see what would happen if DC2 was 1.5 seconds ahead. Let's have a look at that scenario. DC1 gets his change, sends it across to DC2 with his timestamp, 1 second after midnight. DC2 gets a change, but he's 1.5 seconds ahead. His timestamp now says 3 seconds after midnight. DC1 now gets the third change. He passes across to DC2 with a timestamp of 2 seconds, which is correct. And DC2 rejects that change because he says, I already have a more recent update for that change. So he would have rejected an update. Now this is prevented in Active Directory because although he uses a timestamp for resolving conflicts, he also has something called a volatility vector. And we get to that in part 4. However, time skew is not so common these days. Kerberos has also put paid to that. What's the largest time skew you can have in a Kerberos system? Default is 5 minutes. Anything after that, and Kerberos will reject the authentication because he will say this is a replay attack. So it may not seem so important anymore to us, but it's helpful to understand how it is built. So instead of being dependent on a timestamp, what does Active Directory use? They use an update sequence number. Not a universal sequence number. I've seen it in documentation sometimes. An update sequence number. It's local to that domain controller. Each domain controller has its own update sequence number that he keeps track of. So here we have a DC1, he gets a change. he receives it, he takes his USN, he updates it by 1. He sends it across to the other domain controllers. They also update their USN on that server, and when DC2 writes the change into his database, what does he write? His USN, yes, but he also writes the USN of the originating server. Now, what would happen if DC2 went offline? Bit like Grandpa sitting on the sofa, misses a bit of the action movie, wakes up and says, "What did I miss?" What do you say? "Well, I'm not sure when you went to sleep, so how do I know what you missed?" And in DC2, it could happen that he misses a few updates, he goes offline, but he keeps track of the highest USN he received from DC1. He calls this a high watermark. And so when he comes back online, he has the possibility to request from DC1 all the changes since his high watermark. Although on this slide it looks as if he stores the name of the server, DC1, he actually stores an invocation ID. Now we're going to stop here before going into the invocation ID, because this is just a sample. If you'd like to continue this series, or you have technical considerations about what was presented here, please contact me on the address on the slide. Thank you.